Hello there. In this video, I'm going to be showing you how to create a line that cuts through the intersection of two different circles with different radiuses. With the maths derived in this video, you will be able to replicate this Desmos graph right over here. The link to this graph is actually below this video, but I would recommend watching the rest of this clip to find out how to create the maths to get this line that you see on the screen. So the first thing we must do to get the equation of this line is draw the diagram, okay, with two circles. This circle over here is going to have the radius r, and its center is going to be AB, and this circle over here is going to have the radius D, and its center is going to be PQ. Okay, so from here, what we can do is create an equation out of this, and another equation out of this, and these two new equations are going to help us get the equation of this line. So what's the trick to get the line that cuts through the intersection of the two circles? Well, to get the equation of this line, you're going to get the equation of the first circle, expand it, make it equal to 0, make one side equal to 0, and you're going to do the same to the second equation. That is the equation of the second circle. You expand that and you make one of the sides equal to 0 like this. And from here, you can say this over here in yellow, this expression over here in yellow is equal to this expression over here in red. That is like saying 0 is equal to 0. And from there, you can end up getting the equation of this line over here that cuts through the two circles by isolating y. Okay, so we make the new expressions in yellow and red equivalent to one another. And what we end up with is this third step over here. This expression is equal to this expression. And the next steps going forward will be isolating y. And when we end up with y, we'll have our line. Okay, so let's break down this top equation. Since we have an x squared and y squared on both sides of the equation, we can get rid of them. And what we end up with is this equation below. Now what we can do from here is send minus 2by to the other side of the equation. So that becomes plus 2by. We then send the other elements on the right hand side, not including minus 2qy, to the left hand side of the equation, okay? So what we end up with is plus 2by minus 2qy is equal to this expression over here. What we've seen is the elements p squared, q squared, and minus d squared becoming minus p squared minus q squared plus d squared, okay? So when we are sending these other elements to the other side, we change the operations, okay? From here, we can simplify the equation further. We can say 2y times b minus q is 2x times p minus a plus a squared plus b squared plus d squared minus p squared plus q squared plus r squared. Okay, so using the distributive method, we can get this equation over here. And we can make things even neater by putting these values in alphabetical order. Now to get the line, our goal originally was to isolate y. We isolate y in this equation by dividing both sides by 2 times b minus q. So from here, up here, we should get this equation over here. Now, if everything has been done correctly and we cancel out the correct expressions, what we end up with is y is equal to p minus a over b minus q times x plus a squared plus b squared plus d squared minus p squared plus q squared plus r squared over 2 times b minus q. Now, what is really cool about this equation is that you can use the line to find the intersection points of two circles. And I'll be demonstrating exactly how you can do this in my next YouTube video. If you want to find out more about this equation and how it works, just check out this Desmos graph by clicking the link to it below this video. I hope this video turns out to be very useful to you. For more content like this, make sure you are subscribed to my channel and also check out mathematics.proofs on Instagram. Thanks for watching and see you in my next video.